Good afternoon, student. Yesterday we have discussed about some problem. Today we will go for the Newton formula for velocity of Newton's formula for velocity of sound in air. Newton formula for velocity of sound in air. So Newton has given formula and he has also suggested that the speed of sound in air is 280 meter per second. Okay, speed of sound in air is 280 meter per second. But actually, the speed of sound is equal to 340 meter per second. Okay, the actual speed of sound of air is 340 meter per second. But before going to the actual speed, Newton has given one formula and we calculated that speed of sound is 280 meter per second. After that, Laplace has corrected this is the wrong. Only speed of sound is 332 or 340 or 332 meter per second. This is the speed of sound. So we will discuss this formula in brief. So Newton explained that sound travel in air forms a compression and rarefaction. Compression and rarefaction. While traveling the sound in the air, it forms compression and rarefaction. Okay, so it is like that. This is the compression. This is the compression. This is the rarefaction. Like that, it will travel. So during compression, he observed that heat is transferred to surrounding. During the compression, heat is transferred to surrounding. So during the rarefaction, heat is taken from surrounding. During rarefaction, heat is taken from the surrounding. So during the compression, heat is produced. So that heat is given to surrounding. Okay. During the rarefaction, during the rarefaction, heat is taken from the surrounding. Surrounding means it is taken from the air. So he observed two phenomena here. During the compression, okay, he observed that heat is transferred to surrounding during compression. Okay, during the rarefaction, heat is lost here. Okay, that lost heat is taken from the surrounding. Okay, and in this two process, he observed that heat temperature of the processes remains constant. Remains constant. So we have already studied that in thermodynamics, temperature of the system remains constant in only isothermal process. So here I will take isothermal process. So according to Newton, this process is under isothermal. This process is under isothermal. So I will take PV is equal to constant. PV is equal to constant. PV is equal to constant. P is the pressure of a air. P is the volume of a air. This is equation number 1. Volume of air. So now I will remove this part. Now I will differentiate equation number 1. Okay. So differentiate equation 1. Okay. We will get during the differentiation we will use QV, product rule. So first function as it is differentiation of first function means T, second function means V. So first function as it is differentiation of second function plus second function as it is V as it is differentiation of first function. So constant in the differentiation is equal to 0. So constant is equal to 0. Now see here P dV as it is. Okay, I will take this V dP in that side. So minus V dP. So next P as it is V dP divided by, I will bring this dV this side. So it is dV. So P is equal to minus V is there now, minus as it is dP divided by, bring downside. So dV divided by V. So this whole term we have already studied that bulk modulus B, that is equal to B. dP by dV divided by V means it is equal to B. So velocity of sound is given by V equal to root B divided by rho. B divided by, this is the standard formula, velocity of sound is given by this formula is given by Newton. V is equal to root V by rho. So here V as is root B means V is equal to P. Work modulus is equal to pressure. So that I will take, instead of B, I will take P. P divided by rho. P divided by rho. Now see here. In normal temperature and pressure, so the values are P equal to 1.013 into 10 to the power 5 Pascal. So density of air equal to 1.239 kg meter cube. This is the density of air. So temperature is 273 Kelvin. So next, see here, substitute these two values here. V is equal to under root 1.013 into 10 to the power 5 divided by 1.239. Okay, 1.239. So you will get velocity of sound in air approximately 280 meter per second. This 279, you will write 280 meter per second. This is the velocity of sound in air. This is obtained from Newton's formula. Okay, this is obtained from Newton's formula. So, but actual speed of sound in air is 340 meter per second. So, or 332 meter per second. We will take 332 meter per second. So, I will remove this one. After that, one more scientist came here, and his name is Laplace. So he corrected his formula so that you will call it Laplace correction. He corrected the Newton's formula. That's why it is called as a Laplace correction. So here he observed that while traveling air, sound in air produces compression and rarefaction. He noticed that there is no heat transfer during the compression as well as during the rarefaction. He observed that during compression and rarefaction, there is no heat transfer. He observed that during the compression and rarefaction there is no heat transfer. So that he said that this process is a adiabatic process. According to Laplace, this process is adiabatic. Why he called as adiabatic? Because means air is a bad conductor of heat, so heat remains constant. So he called this process as a adiabatic process. So now I will take adiabatic equation. PV raised to gamma is equal to constant. We have studied this constant, this equation in the thermodynamics topic. So I will call this equation 1. This equation 1. So now differentiate this equation. So I will write here gamma is where P is the pressure, V is the volume, where gamma is equal to Cp divided by Cv. This is also we have studied in kinetic theory of gases. Okay, this is the ratio of specific heat at constant pressure to the ratio of specific heat at constant volume. So differentiate equation 1. Here I will take second term first. I will differentiate second term first. I will differentiate first term first. Then I will consider second term. So differentiate V4 gamma as it is. Differentiation of T is dP plus. Next, I will use same product rule only. Okay, don't confuse that. Now take care. P as it is. Differentiation of V power gamma. V power gamma means here differentiation V power gamma is gamma V power gamma minus 1. Gamma V power gamma minus 1. Differentiation of V power gamma is gamma V power gamma minus 1. Gamma V power gamma minus 1. Okay, differentiation. With respect to volume, we have to differentiate. dV is equal to 0. Next, divide this equation by V power gamma minus 1. Divide this equation by V power gamma minus 1. So, see here, V power gamma dt divided by V power gamma minus 1. So, plus P gamma V power gamma minus 1 divided by V power gamma minus 1 dV equal to 0. Okay. Now, see here, V power gamma minus 1, V power gamma minus 1. This cancel. Okay. Next step, we will remove this one. See here. Bring this term upside. So V power gamma. This is the positive plus V power gamma minus 1 is there. So it becomes minus V power minus 1. Okay, minus V power minus into minus plus 1. So dP as it is dP. So plus P gamma dV equal to 0. Okay. Next here, plus gamma and minus gamma cancel here. Remaining is the V power 1. So it is V dP plus P gamma dV equal to 0. Now bring this term to that side. P V power gamma dV as it is, this term equal to minus V dP. So P gamma dV. I will send this term to downside dP divided by dV. So P gamma is equal to, I will take this V downside, so dP divided by minus as it is dV by dV divided by V. So this whole value we are calling as a bulk modulus. So this is equal to B. This is equal to B. Next, velocity of sound in air V equal to under root V divided by rho. So V equal to root B means this is V is equal to P gamma. So I will substitute instead of B, P gamma divided by rho. P gamma divided by rho. Here V equal to, we have already know that some value P is equal to 1.013 into 10 to the power 5 Pascal. So rho is density of air is equal to 1.239 kg per meter cube. Kg per meter cube. And gamma, we have also now gamma for air molecule it is 1.4. 1.4 value is 1.4. So substitute all these values in this equation. V is equal to, P means 1.013 into 10 to the power 5 into 1.4 gamma value divided by density. How much it is? For air 1.239. So simplify this equation, you will get 332 meter per second. 332 meter per second. So this value is close to the actual value. So we are agreeing that the velocity of sound is 332 meter per second. So I hope this concept has explained briefly. Thank you.